Question 9. The melting point of an alloy depends on its composition. Stainless steel consists of 5 and 13% of chromium. And they ask why the melting point of stainless steel is very similar to steel. So you can see it's really very similar. So what is an alloy? If you remember, metal looks like this. Right, metal looks like this. So you have cations in a sea of delocalized electrons. Right, that's metals. So in alloys, we purposely introduce other type of metals. And in this way, it actually creates a mixture. And the purpose is to make it harder because it has now, if it has now irregular size, then the ions are not the same size. It will not be able to slide easily. So it's like something protruding out to prevent the sliding. Imagine if it's bigger. So if that's the case, then we will expect the properties to be a bit different. But we are expecting a very similar property, right? So remember, the purpose of alloy is to disrupt the regular arrangement of the metal ions. So therefore, what we can do is we can go to the data booklet and look at the size. Maybe that will give us some idea. So if we look at the size, we look at table 9, where we look at the size of the metals. And in stainless steel, is actually iron. So you can see iron is about 61 for 2 plus. Okay, chromium is about 62 for 3 plus. Okay, that is the ionic radius. But if we look at the atomic radius, then it will be about 130 and 124. 130 and 124. So why is that they have a similar melting point? Okay, and the main reason for that is that we find that the ion size are about the same. So remember, they are cations in the sea of delocalized electrons, right? So if we go back to the data booklet, if you look at the ion size, this is 62 and this is 61. So therefore, the main reason why it is very, very similar, okay, is because chromium and iron have very similar radius. And the chromium atoms can replace some of the iron atoms to form stainless steel without changing the crystal structure significantly. If you look at the ionic radius of the cations, they are even more similar, right? And therefore, and the attractive force are not significantly affected. So if we look at the charges, they actually can have the same charges. If we look at this one, let's say look at iron have been 3 plus is 55, chromium is 3 plus is 62. So they can have the same charge and then they don't really have a big difference in the size. So in this question, because data is given, so we try our best to explain according to the data. So the data is trying to tell us that it is going to be very similar. So we have to find ways to explain such that it is similar. So when the idea of an alloy is to introduce substances of a different size. So when we uses an alloy, we uses a substance of different size, and when we introduce the different sizes, it actually causes to disrupt the metal lattice structure. But this case, because they are very similar, we will expect that the lattice structure was not significantly altered. There was not much changes to the structure because the radius are quite similar and the charges are also quite similar. Okay, that's the best way to explain the data because the data is telling us that they are going to be similar.